See, augmented matrix means consider the system of equations like a1x plus b1y equals plus c1z equals some d1, and this is a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. Now there are three equations with three unknowns. Okay, we can able to write this in the matrix format. Like the coefficient alone will form a 3 by 3 matrix, that a1 b1 c1, a2 b2 c2, and a3 b3 c3, and the variable alone will form a column matrix x y z. This one is d1 d2 d3. How we can suppose to write like this? We just do the matrix multiplication. See, this is of order 3 by 3, this is of order 3 by 1. Is it? So, it is what kind of matrix? Suitable matrix. Like not suitable, right? We say what? Commutable. It's not complement. Compatible matrix, I forgot. Compatible, okay. So, if you multiply this means a1x plus b1y plus c1z is equal to d1, like we'll get. The same equation I wrote this in the matrix format. So, here augmented matrix means, like we'll call this coefficient matrix as A, variable matrix is X, and this is D. Okay. So, this augmented matrix means, we will mark it as B. B already there, right? Okay, let it be D. So, augmented matrix means it is a matrix of joining the matrix A and D together, splitted by a line. Okay. Or some authors may write AD, but it doesn't mean that it is multiplication. Okay. This augment inside the matrix, we are writing both together. That is what we call it as augmented matrix. Okay. So, in the sense, this A1, B1, C1, A2, B2, C2, A3, B3, C3, and D1, D2, D3. Like they are splitted by a line, or this line may not be there. We call such matrices augmented matrix. Better I suggest that we'll put this line to identify which is which, because based on this we'll have some other results coming up in the next exercise. Okay. Next is submatrix. Consider a matrix of order m by n. M by n means it could be any matrix, like some number of rows, some number of columns may be there. Okay. In this, the submatrix means, submatrix is a matrix kind of subset obtained by deleting some rows or columns. For example, this like one matrix is there. What is order of this matrix? 3 by 4, right? 3 by 4, man. 3 rows, 4 columns. Okay. Now, if I delete only this row, then I'll get 3 by 3 submatrix. Like 2, 3, 5, 8. See, sir, 1, 2, 3 rows. 1, 2, 3, 4 columns. This is 3 by 4 order I written. Okay. This is 7, 9, 9. Let it be 6. Okay. Then this is 2, 7, 6. It is a 3 by 3 submatrix. I think while discussing about this determinant, I told you, not determinant, minors I told you, right? Or we can take 2 by 2 submatrix also. 2 by 2 submatrix means some 2, 3, 8, 4 that alone, or this 3, 5, 4, 9 that alone will take as a 2 by 2, like anything you can take. It's usual. We discussed that, right? Usually element multiplied with their cofactor, that is the concept, whether it is 3 by 3, 4 by 4, 5 by 5, whatever it is. So in the 4 by 4 matrix and all, it will be like 3 by 3, that minor will be 3 by 3. Okay, now shall I erase this? And every element of a matrix is a submatrix of order 1. Every matrix is a submatrix of itself. They are the results. Yes, sir. No? Like the same matrix can be the submatrix, or if you delete one row or one column, still it, if you delete one column or one row, still it is a submatrix. Or these two rows and this one, these two columns and this one row I am subtracting, deleting, then this can be the submatrix. Like that, we can delete any number of rows, any number of columns. Yes. See, we can delete this this column and let it be this row. We can delete. Then the remaining things 2, 5, 7, 2, 6, 6 can be submatrix. No, we cannot exchange. As if in the same order. Okay. Alright. Next, the echelon form. See, echelon form of a matrix is the number of zeros, before every non-zero element in each row is less than the previous row. Okay, so it's less than the next row. Then we obtain such form is called the echelon form. For example, take this matrix 1, 2, 3, 4, 0, 5, 6, 7, 0, 0, 8, 9. This like one matrix is there. Okay. So the number of zeros before every non-zero element of a row. So here, what is number of zeros before every non-zero element of a row? Here no zeros. Okay. So here no zeros. But here, this is a non-zero element, we get 1 0. This is the non-zero element, we get 2 zeros. Like before row and all, having less zeros, right, comparatively. Okay. This kind of form we call it as echelon form. Okay. Now second row should contain less number of zeros than the third row. First row should contain less number of zeros, like before the non-zero element, that is what it matters. Here 0 may come, that doesn't matter. It's about before every non-zero element. The first zero. Before every non-zero element, how many zeros coming? That should be less than the previous row. Okay. Then previous row is. Alright. And then next important topic, rank of a matrix. Rank of a matrix is the order of submatrix. Order of non-singular submatrix like this. Okay, that means we wrote a matrix, right? For that matrix, let me write one matrix. For that matrix, we should be finding the determinant. Let us write this is minus 1, 0, 2 and 0, 1, minus 1. This is a matrix. Okay. Now, say let A be a non-zero matrix. The rank of A is defined as maximum of the orders of a non-singular square submatrices of A. The rank of null matrix is defined as 0 and the rank of matrix A is denoted by rank of A. It is denoted by rank of A like we denote. Okay. The idea is this is a matrix A. Okay. We get 3 by 3 submatrix of this. That means itself only. If you take determinant of this means what? What it is? 1 into 0, 0 minus 2 and minus 2 into this one. Minus into minus plus 1 minus 0 plus 1 into this is minus 1 minus 1 and 0. This is minus 1 and 0. Then this is minus 2 and this is minus 2 and this is minus of minus. It's minus 1. So we get minus 5 which is not equal to 0. So the rank of a matrix is 3. Suppose if this determinant gets 0, okay, suppose if this determinant gets 0, we should go for next submatrix. Next possible order submatrix is what? Submatrix is a square matrix, right? Then 2 by 2 matrix you can write. If this becomes 0, we can go for next. Because, yes, did I said or not? Yes, M by not only. It's not, need not to be a square matrix. Like as you are taking the determinant, you should take this like a square submatrix you should take. So in this definition, yes, the maximum orders of a non-singular square submatrix. Submatrix can be of any order. As you are taking determinant, we should take that into square submatrix. Okay. So this 3 by 3 become not 0. So the rank is 3. Suppose if that becomes 0, the rank is not 3. We should go for next order. 2 by 2 submatrix we should write, square matrix. In that, at least one square submatrix is not equal to 0. At least one square submatrix is not equal to 0. We say the rank is 2. Suppose all the 2 by 2 are 0. We say the rank is not 2. We will go for 1 by 1. The rank is 1. Like that we can write. Okay. See, this is one example. We got 3 by 3. We got 3 by 3, right? Now 2 by 2, if 3 by 3 becomes 0, we can take 2 by 2 matrix. Like we'll have, yes, all the 6 should be determinant equal to 0. If at least 1 is not equal to 0, if at least 1 is not singular, then we define rank is 2. but all the 2 by 2 are become 0 means, determinant become 0 means, we'll go for 1 by 1. So it is not possible that 1 should be non-singular means we say it is rank is 2. Okay. But maximum we'll try to obtain a echelon form. If square matrix is given, you can go with this idea, but as we discussed, it takes so much time, because here 3 by 3 itself getting not equal to 0. Suppose this 3 by 3 becomes 0 means we should get all the possible 2 by 2 matrices, like it is not only this batch and this batch, this first and last also can be combined. So many possibilities are, all the things we should check. If at least one getting not equal to 0, one getting non-singular also, we will define. Suppose we checked only for 3, it becomes all that becomes 0, but we should not define without checking everything, we should not finalize the rank is 2. Okay. So the thing is, we should obtain only row echelon form, after that we will decide the rank. Okay. Now, what it is, rank of a matrix done, and then there are some notes. A is a non-zero matrix of order 3 by 3, then the rank of the matrix is A, like this what we discussed. So the rank is 1. When the rank is 1 means, if every 2 by 2 submatrix is singular, that we discussed, and the rank will be 2 if A is singular, that means this becomes 0, the determinant of A becomes 0, and at least one of its 2 by 2 submatrix is non-singular. That point also we discussed. Okay. And the rank will be 3 if A is non-singular. Here A is non-singular. So the rank is 3. Okay. You got the understanding or you got confused? 4 by 3 means we should take the determinant. If that determinant is become 0 means, see, as we discussed, 4 by 4 determinant is, it's big to work out. So we have row echelon form to reduce that. Okay. Alright. That I will say next topic is like that only. Okay. Okay, this is for square matrix we are taking, square submatrix we are checking. Okay. Suppose it is not a square matrix, then what it will be? Suppose here another row is there, like 2, 3, 5, another row is there. So in this method, how we will check? All the 3 by 3 possible submatrix we should write. Okay. So here all the 3 by 3 submatrix will be not equal to 0 coming. For example, I am saying not equal to 0 coming. Then the rank of a matrix is, the rank of the matrix will be the minimum of m by n. The minimum of, rank of the matrix will be less than minimum of mn. That means here m is the number of rows, n is the number of columns. In that, suppose here 2, here 3 means the minimum will give you only 2, minimum among 2 and 3. So the rank will be less than or equal to 2, like we can decide. Okay. Alright. It sounds confusing. See, you are always sticking on the 4 by 4 matrix. The thing is, we don't literally calculate determinant of 4 by 4. We will do with the row echelon form. That I will tell you shortly. Now